Here in this video, we are trying to derive an expression or try to understand the gas pressure when it is placed in a test tube like this. Let us consider a test tube like this in a horizontal position. One end is closed, the other end is open. Somewhere in the middle, you imagine a mercury pellet having certain length. We can call it like small h, whatever. Imagine there is some gas inside. So what this gas will do? This gas will have some pressure on this mercury pellet. Let me call that as P gas. This mercury pellet is open to atmosphere, that also will have a pressure. So that atmospheric pressure will always try to push the mercury towards that of the left, whereas the gas will try to push it towards that of the right. So we can say pressure due to the gas in the direction of right equal to pressure due to the atmosphere in the direction of left. What is the formula for the pressure? As for the definition of pressure is defined by force by area of cross section. That implies force can be written like pressure into area. That implies force of the gas can be written like pressure due to the gas into area of cross section. Assume this area of cross section is uniform for the tube, that is constant, and the gas has occupied the entire area, entire volume, equal to pressure due to atmosphere is P naught into A. Both areas gets cancelled. So pressure due to the gas on the mercury pellet is atmospheric pressure itself, where atmospheric pressure can be written like HdG, where H is 76 centimeters of Hg, that is of mercury. Density of the barometer do measure this. Density of the mercury is 13.6 gram per cc. Acceleration due to gravity is 9.8 meter per second square. So this 76 can become 0.76 meters of Hg. This becomes 13.6 gram is 10 power minus 3 kilogram by centimeter is 10 power minus 2 whole cube meter cube. So that's value becomes 13.6 into 10 power minus 3 by 10 power minus 6 kilogram per meter cube, that is 13.6 into 10 power plus 3 kilogram per meter cube. So if you try to calculate how much is that atmospheric pressure is, P naught is 0.76 in SI system, density 13.6 into 10 power 3, G value 9.8. So that's value is approximately 1.01 into 10 power 5 Pascal. That is called actually 1 atmospheric pressure. People also call it like 1 atmospheric pressure. Regular pressure of the atmosphere is called 1 atmospheric pressure. Its actual value is 1.01 into 10 power 5. That can be found as I have explained in the video. All this when the tube is in horizontal mode. When the tube is in horizontal mode, we can derive an expression like this. But tube need not be horizontal always. If the tube is in vertical mode, we will derive an expression for the tube is in vertical mode now. There are again two possibilities. What are the two possibilities are? It is in vertical mode in such a way that its open end is open to atmosphere and vice versa. Let us discuss this case now. Let's imagine a mercury pellet in this tube. Let the length of this mercury pellet is small h. There is some gas here. Atmosphere tries to push this mercury pellet down. Gas will try to push it up. Somewhere a mercury pellet got balanced and a At equilibrium, what we can write? Force in downward direction is force in upward direction. But I want you to be careful that this mercury pellet also will have some mass and its weight always acts in a downward direction. So what is the total force acting in the downward direction is force due to atmospheric pressure, this force, plus weight is also acting in downward direction, is force due to the gas in opposite direction, upward direction. Force is pressure due to the gas into area. So force due to the mercury is due to the atmosphere is P naught into A. Mass of the mercury can be written like volume of the mercury, density of the mercury into acceleration due to gravity, equal to pressure due to the gas as well as area. This can be further simplified as P atmosphere into A plus volume of this mercury pellet can be written like area into length of that mercury pellet. Length of that mercury pellet, as I told, it was H, and dg equal to pressure due to the gas and areas. So all areas in common can be cancelled. P naught can be written like capital H dg, where H is 76 centimeters of Hg, plus small h dg, where small h is the length of the mercury pellet, equal to pressure due to the gas. So pressure due to the gas is small h plus capital H dg. That's the pressure due to the gas. Then this is expressed in automatically Pascal, right? So we want to express it in terms of meters. What we can say is H plus H of dg can be pressure due to the gas is also equal to some height x. Again the same mercury, same acceleration due to gravity. Both of them can cancel. So length of that column due to the pressure experienced by that gas, pressure applies the gas of H plus H. This becomes meter of Hg, as you have expressed it in terms of meter of Hg. This is in vertical mode when the open end is on top. But we have another option like that open end need not be on the top. So I can draw the vertical tube, test tube, and the open end is in downward direction. Everything is same. Imagine a mercury pellet of height h. This gas will try to push it down, that is pressure due to the gas. Its weight obviously always acts in downward direction. Atmospheric pressure applies a force in upward direction, right? So I can write at equilibrium, total force downward is force acting upward. What is the total force acting downward is force due to the gas, that is pressure due to the gas plus area plus weight of the mercury pellet, is force upward, that is force due to the atmosphere, that is P naught into A. So pressure due to the gas into area plus this M can be written like area into HdZ, as I have written, equal to P naught into A. Area is common, that can be cancelled. So pressure due to the gas is P naught minus HdZ, where H is the length of the pellet. Atmospheric pressure P naught can be written like, as I told you, HdZ, where this can be called capital H. So HdZ minus HdZ, that is H minus H of dg. If you notice carefully, earlier you got H plus H, now you got H minus H dg here, H of this much of Pascal, that is pressure due to the gas. If you want to express it in terms of the length, x dg, where d is density of mercury, g is acceleration due to gravity, H minus H of dg, this dg's can be cancelled, then x is H minus H meters of Hg. So you can find out the pressure. All this is basing on a simple concept that the forces are balanced. We are just using the equilibrium formula to solve. We are identifying only the forces acting. Pressure of a gas always tries to push the mercury pellet up. Atmosphere always tries to act in a direction that is shown to you. Weight, of course, always acts in downward direction, right? That's how we can understand the position of the test tube and the gas inside the test tube. That's it. Thank you for watching.